So we'll get started here in just a second when our panel fully assembles, and we'll see if we can go through this. So I pounded you with content. I'm sure there's a lot of information that you'll be able to seize on in the next hour, and hopefully somebody will hear somebody other than myself talking for the next hour. So I'm going to start off with a little introduction of the panelists, as well as the organizations that they come from. So first of all, I want to start off with Amy Kaslow. Amy is an independent economic development consultant and senior fellow at the Council on Competitiveness. Amy brings a mix of policy analysis, practical experience, and contemporary coverage. Amy builds community-based workforce solutions for a wide array of stakeholders competing in an economy characterized by dramatic change. Her approach is intergenerational, giving the biggest pressures on the joblessness and job generation, would-be new entrants and mature 55-year-plus workers intent on remaining in or returning to the labor market. Galvanizing business, education, labor, grassroots, and government leaders to collaborate locally, she helps prepare new graduates for a pipeline of talent to tap and refine the expertise and the experience of older workers and to share those innovative, scalable, and replicable practices nationwide and abroad. Amy has conducted field work, consulted, written, and testified for congressionally mandated commissions and federal agencies, among them the House Science Committee, the 21st Century Workforce Commission on Knowledge and the Economy, the Glenn Commission for Improving K-12 Teaching, very impressive, National Academy of Sciences, National Science Foundation Study Panel, examining national workforce data for the United States Census and the U.S. Departments of Commerce and Labor and the White House task forces. The Council on Competitiveness is located here in Washington, D.C., and was founded in 1986 during a time when the United States was facing its most dire economic challenges at the end of World War II. It began as a presidential commission empowered by President Reagan to look at the lagging productivity of the United States and was chaired by John Young, then chairman and CEO of Hewlett-Packard. The country had slid from being the world's largest creditor to the largest debtor. Its position as a global leader in technology and innovation was declining, and American industries were losing market share to international competitors. Mr. Young was so passionate about their work, he helped continue the work as a 501c3 following the official role for President Reagan. The Council on Competitiveness brings together university, national laboratory, and labor leaders and business leaders as a forum for elevating national competitiveness to the forefront of national consciousness, and the Council on Competitiveness celebrated its 25th anniversary last year. Amy, thank you for joining us.
My pleasure.
I think I'm supposed to flip to the next chart and see who that is. All right. Edison Welding Institute. We have Chris Conrardy here with us from the Edison Welding Institute. Chris has over 25 years of experience in developing and implementing the advanced manufacturing technologies. He holds a BS and MS degrees in welding engineering from the Ohio State University. He's done work for a wide range of industries, including the heavy manufacturing, energy, defense, aerospace, and automotive sectors, and he's currently the Chief Technology Officer and Vice President for Technology and Innovation at EWI, a position he's held for 5 years. In his current role, Mr. Conrardy is responsible for identifying emerging industry needs and investing in development of advanced manufacturing technologies to address those needs. He manages EWI's capital investments, internal research portfolio, intellectual property portfolio, and technology commercialization activities. EWI is based in Columbus, Ohio, and it's a nonprofit engineering services company that develops and commercializes advanced manufacturing technologies to improve competitiveness. EWI is North America's leading engineering and technology organization for materials joining and materials forming and allied manufacturing technologies. It provides confidential research and development services, technical assistance, and training to over 3,000 member company locations, and its laboratory facilities include a wide range of full-scale, leading-edge manufacturing processes to enable clients to pilot test new technologies for their products. Chris, welcome, and thank you again for joining us. All right. Dr. William Hartman. Dr. Hartman is Executive Vice President and Chief Operating Officer of the FRAUNHOFER USA, and it's headquartered in Plymouth, Michigan. FRAUNHOFER USA operates 6 applied research centers around the country. They're partnered with major U.S. research universities and Fraunhofer institutes in Germany. He's responsible for guiding and promoting strategic development and growth of Fraunhofer centers and fostering expanded cooperation between Fraunhofer institutes in Germany and the academic, state, federal, and industrial partners in the U.S. In 2010, he received the prestigious Fraunhofer Medal in recognition for his outstanding achievements in continuing the development of Fraunhofer USA. Fraunhofer USA performs applied research under contract to government and industry customers such as federal and state governments, multinational corporations, as well as small to medium-sized companies, and Fraunhofer's research benefits society in many ways. Fraunhofer USA is a subsidiary of Fraunhofer in Germany, a world-leading applied research center which has over 80 research units, including 60 Fraunhofer institutes at different locations in Germany. Fraunhofer has an annual research budget of over 1.65 billion euros. Each Fraunhofer USA research center is closely affiliated with at least one of the 60 Fraunhofer institutes in Germany. They also cooperate closely with major research universities in the U.S. Bill, thank you so much for joining us as well.
Thank you. Pleasure to be here.
And last but not least, Dr. Johnny Green. Dr. Johnny Green graduated magna cum laude from the University of Memphis with a Bachelor of Science degree in Mechanical Engineering. He received his master's and PhD degrees in mechanical engineering from the Georgia Institute of Technology. Dr. Green joined the Oak Ridge National Laboratory to conduct research on cyclic variability in internal combustion engines. During that research, he joined a team at the Ford Motor Company seeking ways to extend exhaust gas recirculation limits in diesel engines. He continued his research collaboration at Ford Scientific Research Laboratory on modeling and experimental research for advanced diesel engines designed for light-duty vehicles. He participated in an assignment for the U.S. Department of Energy's Office of Freedom Car and Vehicle Technologies, serving as a technical coordinator for the 21st Century Truck Partnership. In addition, he serves as a deputy program manager for Oak Ridge National Laboratory's hydrogen and fuel cell research activities. Oak Ridge National Laboratories is a multi-program science and technology laboratory managed for the U.S. Department of Energy by UT Battelle. Oak Ridge's mission is to deliver scientific discoveries and technical breakthroughs that will accelerate the development and deployment of solutions in clean energy and global security, and doing so create economic opportunity for the nation. They also perform other work for the Department of Energy, including isotope production, information management, and technical program management, and provides research and technical assistance to other organizations. Dr. Green, again, thank you for joining us. So with that, in my last hour, I'm sure you're tired of hearing me talk and speak at this point, so I'd like to open up the panel. We obviously have a panel here that's got tremendous experience in science and technology. So I tried to make the case over the last hour innovation is the key to competitiveness. So let me turn to my panel members and say, did the CEOs get it right? Is that what's most important for a nation to compete? Dr. Green, what do you think?
I agree with that assessment that talent, innovation is one of the key elements in this area, but you also have to have the right ecosystem in place in terms of a desire and a commitment of the nation to pursue this, and we've got some opportunity to improve in that area in terms of where we are from an education standpoint. You know, you showed where the U.S. stands right now, so we've got a little bit of gain in the ground. So we need to emphasize education a little bit more, emphasize manufacturing more, and really put a strong emphasis behind this area to maintain and increase our position.
Dr. Hartman, Bill, if I may, you've got experience obviously with both the U.S. and Germany, but they ended up very high on the list in terms of competitiveness today, in terms of innovation. Do you agree with that? And is it CEOs have it right?
Yes, I think so in general, but I'd rather try to focus more on the specifics in the U.S. and certainly it's reflected in quite a bit of your data. And that is from the educational aspect. Innovation, I always say, consists of two essential ingredients: ability and imagination. And I think it's important that we start being more innovative with respect to the education that we are providing in this country. Without having better qualified people coming out of K through 12 into high school and on to college, we are never going to catch up. That's my sincere belief. And I think that it's important to make things. It's important to make people too. And if we don't focus on making people by having better systems, then we are not going to make better things.
You know, each of you require significant talent to drive your organizations, right? Whether it's Oak Ridge National Labs, EWI, Fraunhofer USA, or even the Council on Competitiveness, we require top talent to be able to look at this stuff. So Chris, let me turn to you and then open it up to all the panel members. Do you have trouble securing the kind of talent, the deep expertise necessary for some of the projects you do at EWI?
Well, that's a great question. EWI, our clients really rely on EWI to have leading edge talent. That's really what we sell, is our talent in combination with technical expertise and physical assets that companies really can't afford to maintain by themselves, so they use us as their technology development arm. Talent attraction and retention is one of the key pillars to our company strategy. And the way we do that is to create an environment where folks that like a very diverse opportunities to work in a wide range of technologies with a wide range of customers can really thrive in that. So it's very attractive to those type of people. But absolutely, it's a very competitive market. One of our challenges is our folks do work with clients ranging from manufacturers of consumer electronics to food packaging to aircraft carriers, so they get a lot of exposure. And so they're out there on the front line when somebody's looking for talent.
Right.
So we have to spend a lot of time to make sure that they're very happy, and that we're trying to get the cream of the crop out of the universities for sure.
Do you sense that there's a skills shortage or a gap in terms of the availability of what you need versus what you'd like to have, much like the CEOs are saying, they're telling us?
Absolutely. And in fact, EWI is a little bit unique in that we are a member-based organization, so we have very long-term relationships with a lot of industrial clients. Those clients we've asked through focus groups and surveys and conferences. They repeatedly tell us that leadership in advanced manufacturing technology is absolutely vital to their future competitiveness. And you really can't adopt advanced manufacturing technologies without the expertise to understand how to design with them, how to apply them, how to continue to evolve them. And there is definitely a shortage in that, and it's getting worse because technology is advancing so much more quickly that the education system can't keep up with the technical advancement.
So let's talk a little bit about, particularly for the three of you, we got some great questions for you. Hang on. So a little bit for you, when you think about what is the future of manufacturing technology? You're all working on some extraordinary projects, and I thought we could talk to the audience a little bit about what are some of those projects, because understanding what things you're working on, what are the breakthroughs that you're working on, what's going to go into the marketplace from a manufacturing standpoint, helps us understand a little better when we say we need skilled workers, we need scientists, to understand what they're trying to do. So, Bill, let me turn to you. What are some of the most interesting, innovative things that Fraunhofer USA is?
Within Fraunhofer, we pretty much cover a very broad spectrum of things. But at the top of the list these days is certainly things like health and transportation, communication, the security. These are some of the hot topics for the next 10, 15 years. And so we find that because we're so diversified with respect to talent, with respect to ability, we have people in life sciences, engineering, mathematics, psychology, et cetera. Because of that diversity and multidisciplinary type of resources, we're able to put the right teams together in order to be able to advance something. After all, what innovation really is making things better and also finding ways to better make things.
Right.
So that's really the spirit of moving forward. You can't do it by being a mechanical engineer only. You can't do it by being a biotechnology scientist only. You have to have a lot of resources available to you in order to get there quickly. when it comes to competitiveness, you not only have to do it better, you have to do it faster. So it's very important to focus on whether you have the right team in place to move quickly to get to the goal line.
Johnny, at Oak Ridge National Labs, you've done some really interesting projects. Let's talk a little bit about that technology so, again, the audience can understand what is this stuff we're developing, and because it clearly makes its way into the marketplace.
Sure. Well, at Oak Ridge, we are also engaged in a wide range of research activities, but related to manufacturing in particular. A little over a year ago, we were awarded DOE's Energy Efficiency and Renewable Energy's first manufacturing demonstration facility. And there are two key research areas that facility focuses on. One is additive manufacturing, and that includes both metal-based and polymer-based additive manufacturing techniques, and we've got several different approaches and several different pieces of equipment related to that. And we also have an emphasis on carbon fiber. And so we have a new carbon fiber technology facility that is being set up right now and should be operational within the next year or so. And the objective of that facility is to help reduce the cost of producing carbon fiber, which has a great potential to reduce the weight of vehicles and improve fuel economy. And so in the manufacturing demonstration facility, we've had over 700 visitors who work very closely with industry. A lot of the approaches that we've used have actually, as you mentioned, made its way in the industry. But related to talent innovation, another thing that we've used the facility for is to actually do STEM outreach. And so there's a robotics competition, a national competition, and last year we opened it up to several high schools, and we had, high school students in the buildings on weekends and in the evening to develop robots for this competition. The competition last year was to develop a robot that could shoot a basketball, and so we had a laser sighting targets on the robot. The robot could take a ball and shoot it, and the kids made all of it, and they use polymer-based additive manufacturing to design the robot system. So, you had kids who, may not have been hands-on developing new things. You put it in the CAD file, you print it out, and some of the kids even came up with patentable ideas. So that was a great way to engage STEM outreach and to help support the next generation of talent in this area that's,
Right.
we really need it.
Well, Deloitte's a sponsor of FIRST, and as part of that, I got an opportunity to compete in one of those basketball shooting robot contests, and I want you to know that our team won. It has something to do with my robot under my control knocking the other robot out of the way. But it was amazing with how engaged the students were and how really advanced the technology was for high school students or junior high students. But when you look at the types of technology you're developing, and Chris, you're doing things with additive manufacturing as well. What kind of worker do I need to both develop that, and then who's going to be using it in the marketplace, right? I mean, what do the skill sets look like of the people that have to do that? Because that's the workforce we're trying to develop.
I think there's even a more fundamental question is,
Okay.
I think manufacturers today are struggling with the explosion of different manufacturing technologies, different materials, different design approaches. Even just figuring out which ones to target for their applications is a major challenge for manufacturers. And then once you've done that, how do you take something that may not be completely mature for a given application, get it matured, then acquire the talent you need to operate that and to internalize it. So it's a whole ecosystem thing beyond just the talent. It's actually identifying the technology, reducing it to practice, and then having the talent to support it.
So Amy, you've done a lot of work in this area looking at the talent development pipeline and the gaps in that pipeline and the multi-generational aspects of it. What's your thoughts about the talent that's necessary and how we deal with some of that?
I'm going to pick up on pull a lot of threads here, try to weave. We look at the two biggest pressures, as you said in your remarks, on joblessness and job generation. The would-be new entrants, the 16 to 24-year-olds who generally lack the skills and the experience to move into productive economy. And then the 50 plus who have enormous skill, and there are many folks in the audience here who are very skilled in this area as well and know this demographic group, but it is the largest demographic in the workforce and burgeoning. It's actually exploding. And we toss around a lot of data. This is a Department of Labor, is BLS data, which we all joke would be revised next week or next month. But between 2010 2018, 90% of the increase in the labor market will be generated by mature workers, 50 years and older. So that's a really profound statistic.
Yeah, very much.
And then of course we have the 16 to 24-year-olds. This should be, the 16 to 24-year-olds and the mature workers, the so-called 50 years and older. They really see themselves oftentimes as competitive, and there's so many ways, drawing on all of the needs and the comments made here, to make these two demographics complementary. So in manufacturing in particular, companies are really positioned to be the epicenter, to really be the generator of local economic development. And I think you hit an important issue, which is first decide what your application is going to be. Companies often, we talk to a lot of companies as well, and as Craig noted, we talk to a lot of folks who run companies, and I always approach it from the, have you done sort of a diagnostic scan, an environmental scan of your workforce? Do you know who you have? Do you know who you have in terms of capability, in terms of education, in terms of ability to take on new skills? And also, do you know who you have in terms of age and tenure? Do you know what you will need to stay competitive in the next 3 to 5 years? And that's a question to answer, especially for the folks you're talking about. And if you do you know the skills that are going to be required to realize those goals? And do you have a pipeline of talent? And if you don't, what are your plans to tap into a pipeline if you don't have one built in, or if you don't have one already organized? And so much of this, while we talk about multinationals and people, looking to Asia and every other continent except for America, so much is local, and so much of what can happen on a community-based level is replicable throughout the country and throughout companies' presence abroad. And I'll get into more specifics as you move through your questions. But
well, let me pick up on one of the things
Yeah.
you said, because Bill, you and I had talked about this before. Amy touched on it. Let's start, because we've talked about both the older worker and we've talked about the K through 12. So let's start with the older worker. But you've talked to me about how important it is to continue learning. And give me your thought. Give us your thoughts on.
Well, first of all, I think that for a person coming out of school and getting some experience in the workforce and so forth, for him to be innovative, he first has to be interested. He's got to think outside the box, which is the imagination part. But then he has to always continue to learn. I used to tell my students when I was a professor a long time ago in graduate school, I'd tell them that the most important thing you learn as you're trying to get a PhD is how to learn, because you will never stop doing that. And once you stop doing that, then you become simply a skilled labor worker. You have to always adapt. You have to always be moving forward, learning new things, and never be afraid of learning new things. Always feel that you can. And I think that's extremely important. Things move so fast today with respect to technology that if you don't say, first time I heard about that, I better learn more about it. You have to do that in order to stay ahead.
As each of your organizations, do you do things to help and promote for your researchers, engineers, continuous learning and advancement? And how do you go about that? What are some of the best practices you use or you believe are good practices to develop that? Johnny?
Well, the nature of our work, in a certain sense, helps to promote that. We encourage publishing our research and interacting with the scientific community. So in addition to, short courses that people may take, also just interacting with the technical community through conferences, organizing conferences, just that interaction and discussion with the technical community continues to help you sharpen your skills and push things along.
And having those high standards for publication and
Yes.
peer reviews
Yes.
certainly helps, right? Chris?
Well, I think what we try to do is we have a very flexible workforce, and we encourage innovation. So I guess we're located in technology verticals that cut across markets. But we try to broaden those technology verticals by asking our folks to innovate those and push the limits. So, for example, we've always had a strong expertise in high-power ultrasonics. It's an area that you use for ultrasonic welding. We adapted that and came up with a technology for ultrasonic additive manufacturing. We adapted that, came up with a technology for ultrasonic machining, ultrasonic soldering. So we keep broadening. We take a core technology we have and we broaden it. And as we do that, our junior staff are getting involved in that and really learning about a whole new technology space.
What about I think everybody's talking about K through 12. I implied there's some gaps in certain areas. What's the answer? What do we need to do, at least in the United States, K through 12? What are other countries doing that are good practices or leading practices that you've seen or are aware of?
I'd like to give you a good example.
Sure. I'd love to.
Really powerful example. So I'm so pleased that you're here with representing Oak Ridge, because the national labs, the federal labs are critical. They're critical not only for what, the incredible innovation, but also as multiplier effects in communities. In Tracy, California, there's a school called Tracy Learning Center. It's a beat-up, old, corrugated metal roof, one-level former elementary school that now houses 1,200 students, K through 12. K1 is together, 2-3 is together, 4 is a bridge to middle school, so it's independent of itself. 5-6 is together, 7-8, and then 9 through 12 are by themselves. It is a school that is a charter school. It is in a majority-minority population. It's fairly economically challenged, not totally. It's also in the shadow of a national lab, Lawrence Livermore. The students, it's a very STEM, really STEAM, with the arts in there, infused curriculum. It's online. It was developed by a fellow who's been superintendent of California schools 30 years. His last gig was in Sacramento. His name is Keith Larrick. Really an innovative educator. What he's done is taken kids and put a premium on the learning and the experiential and the team-based, project-based approach. It's not, here's math now and science this afternoon. It's completely interdisciplinary, and it's taught by problem. So you may be teaching the lessons of the Holocaust, and you may be looking at geography, mathematics, engineering, linguistics, all manner of narrative science, such as it was, etc. Remarkable approach. Again, a tough to educate population, and many of the kids go to the school fleeing pretty broken systems that they have not been able to handle, or they've been, they're dropped out, or they've been kicked out. Not one dropout in 10 years. The students log, I think it's 200, I may be misspeaking now, but 100 to 200 hours in internships with a local engineering firm or IP legal firm, or in a local lab, et cetera, or on a floor doing welding. They do about 100 hours of community service because they understand that this is very much a community-based effort, and they learn the value of giving back. There is no gymnasium, there is no science lab, there's no library, there's no lunchroom. They eat outside on these metal picnic tables, and they come in when it's foul weather. Remarkable attention to emphasis on mastery of lesson and not on speed. all of them have internships and mentors, and they connect with the lab as much as the lab can allow. And I think Livermore is interested in doing more. This kind of example is really exemplary, because these students graduate with the sense that they can accomplish what they want if they forge ahead. Their paths, they're well trod already. They don't necessarily have to take that path, but they have a sense of can do, and they have a tremendous amount of STEM infused in their learning, and they have the ability, Bill, to learn how to learn. And that is, tapping into, you said imagination is critical, but tapping into curiosity, we tend to kill our kids' curiosity in K-12. It's probably dead by middle school in many zones, and this ignites it.
So EWI, you do an outreach into the student population and the community. Tell us a little bit about that and how effective that is.
Absolutely. So we have formal programs where we collaborate with universities. So that's kind of on the formal level. But informally, we encourage our associates to engage with the community, and it's something that they want to do. And in many cases, we're bringing in primary school or secondary school students to see advanced technologies. And for example, last few years we've hosted the Columbus School for Girls, which I believe are eight-year-old girls, and they always leave really jazzed about manufacturing technology.
Right.
And the idea is to really get them excited, or at least thinking about this could be a career that they want to consider. But I also think it needs to start at home, because amplifying what you had said previously, we held a conference 3 or 4 years ago. It was a welding-related technology conference, had maybe 300 people there. One of our keynotes started off by asking the attendees, how many want your kids to be doctors or medical professionals? And he went through a whole list of professional things, and he said, how many would like your kids to grow up to be welders? And there wasn't a single hand went up.
Right.
And this was in a room full of welding professionals. So what does that tell you about what our parents are telling their
Right.
kids?
Exactly.
Mm-hmm.
So, Johnny, you described some of the stuff you're doing in the robotics. Is there other outreach that Oak Ridge National Labs does in the community, the mentoring process?
Yes, there is. At our organization, community involvement is also another core value that we have, and we engage a lot of the area high schools, working with mentoring, tutoring. Oak Ridge High School, we have very close collaboration with them, and have helped them implement some new science and technologies, such as a geothermal system underneath the field there.
Right.
So we've tried to expose them to advanced technologies. We have internship programs. We work close with Oak Ridge Associated Universities. So we also try to formally and informally reach out to the community and expose folks to science and math. But I agree that we need to do a better job of trying to make these career opportunities seem more attractive. Quite often folks think about the medical profession or things that they see on TV or other venues, and so careers in this area, I don't think a lot of folks know what the opportunities are, and so we've got a little bit of a disconnect, as you mentioned in your presentation, between what the opportunities are and being able to find the talent. So I think we need to do a little bit of job of educating the public about careers in manufacturing and in science and technology, to make sure that folks know what the opportunities are there, and that we get them focused in the right areas.
Part of this sounds like a public relations effort, right? We see it over and over again. We hear a lot about innovation in Silicon Valley, and new software and new personal communication devices and other types of things. And yet when I had a chance to talk to a number of the national laboratory leaders, as you and I spoke, and all very politely said, well, that's interesting, but it's not really the kind of innovation that requires serious science, serious scale up, et cetera. Do you believe that we can turn the types of things that you do and the things that created enthusiasm 20 and 30 years ago with the space program to excite students today, because today they're excited about the next smartphone and the applications they can get on that, and they think that's innovation. And it is innovation in a lot of ways, but it's certainly very different than what you do and what's necessary to drive a significant economy. Perspective, Bill, what do you think? I mean, how do we turn
Well,
this?
if we're talking about K through 12, then it's difficult for us at our level to really interact with them. We do an awful lot of interaction. We have a lot of interns from colleges that come, and of course one of the problems there is that many of them come from other countries, and they're with us for 6 months. They learn a great deal. They help us, and then they leave. So that's not really helping us long term. We need to do something about fixing that. But what we're really talking about here is motivation. How do you get kids in school to be more interested in learning math and science and so forth? And I think, as Chris mentioned, I mean, there is a certain responsibility that the parents have to encourage that. I mean, it was customary years ago in this country that parents insisted that their kids do well in certain courses. And one of the problems that I think students have, we've all been there when we were going to school. Why am I learning Latin? What good is it? Why am I doing this calculus? I don't understand what can I do with this calculus? I want to play with my iPhone. I don't want to learn calculus, So getting them exposed to something that is applied, getting beyond the classroom, showing them that, don't you think this is neat? You cannot do this unless you have the education to move up to this level. This is something, if you want to do this, then you have to learn mathematics. You have to learn some science.
But it also can work, if I may, incrementally, which is, okay, here's what you're learning. This is how what you're learning applies to making this or exploding this or whatever. And the applied learning is critical in K-12, and the parents are critical. And if you look at having an experiential, very connected, community-connected school in the capital of every state across the country, or in the shadow of every national and federal lab, and have not all the IP on the shelves can be commercialized, but there is a lot of it sitting there that can be. And I know there's some VC folks in our group today. There's a lot of opportunity there to take this stuff off the shelves, commercialize it. The biggest challenge is producing it. Who do we have to actually man and woman the shop? Pretty tough if we're talking about a dramatic skills challenge here. And so I think when you talk about getting on the bully pulpit or making this a public relations campaign, it's one thing to put a billboard up. It's quite another to establish a school where there's media, where there are legislators, where there are folks who are leaders in the community who can really champion this kind of experience and this kind of education. And parents, by the way, in California, there are 200 superintendents who want this particular model in their respective school districts because there's such a strong groundswell in their local communities for this kind of experiential, very community-based school.
Let's talk about that. Is the target audience the student or is it the teachers? I mean, where's the problem? Chris?
That's a great, I think it's both. I think you have to excite the teachers first, and I think that's where one best practice is the teachers' camps that really expose them to some advanced technologies. But I think another emerging best practice, like in the state of Ohio, they're creating a curriculum for secondary schools around a technology area. In Ohio, it happens to be automated materials joining. But the idea is you have specific applications like how would you build a cell phone? Things that kids can relate to, and then they learn some specific element of that, but where you have to do engineering, where you have to do mathematics, where you have to do physics, and it's kind of rolling it all into an experimental paradigm.
Right.
So
it's team-based.
And it's team-based.
And it's entrepreneurial.
Right, and you're learning language skills, and it just is, it's putting it much more in a context where kids want to learn. And and maybe they don't even know they are learning.
We need to really begin to focus on creating intellectual property for education. In other words, the perspective that we have with respect to advancing manufacturing and being more competitive in manufacturing always comes down to doing something that somebody else hasn't done yet, getting it protected so I can make money using it, all right? And then you have an Apple or you have a Microsoft. That's the sort of thing we need to do in education. We need to come up with innovation. We need to have new ideas, new concepts that we can protect and say, this is the way we're going to do it here, and make a much better supply of human resource available for manufacturing. So innovation, has to go all the way down to the very beginning of the resources that you need in order to have better manufacturing.
I'd like to make just one final comment on that topic. I think in addition to the teachers and the students, the parents also, as we mentioned, have to be involved. So you have to hit all three. And in terms of innovation and IP and tangible examples, I think back to, once again, the manufacturing demonstration facility and the polymer-based additive manufacturing. We've had some of the students come in, and what we do with them is we try to get them to see how they can use this to actually make something that maybe they could start a business around. And so, for example, we had a student come up with a cover that you could have for a smartphone, and you can maybe put a logo of your school or things like that, so they can go out to, go back to school and then use that to create their own business. So you can buy one of these machines for a few $100s. You could then, start a small business, selling things that you develop and manufacture yourself. So I think that's a great example of what we should be doing.
So we've got audience Q&A, and Jennifer, I think you're teeing those up. So if you could help us.
Learn about your host today. I assemble smart people to deal with really, really difficult questions. And what I've heard the panel speak to very extensively is the role of the public system. And I want to turn the mirror a little and say I have met the enemy, and it is us. I actually sat next to a manufacturer less than a month ago, having lunch, at which point they said to me, justify to me how I explain to my board members that I need to engage in the education system. What do we need to do as manufacturers to understand that this truly is not just a public issue, but this equally is a private issue? So to the experts and all the brain power you have, how do we overcome that challenge within our community?
Can I add
Sure.
a refinement to that question? It's an excellent question. The corporations spend something like 0.001% of their take-in on community economic development. It is a very big deal in the PR sense, but a very small amount in the actual outlay. Yet human capital is really, if they don't have human capital and very, very dynamic human capital, they can't take it in, right? So I'd like to ask just to what extent the private sector can beef it up and reach out. And I've seen great examples of it. I don't want to take your questioning
right ahead.
role, but it's a rhetorical question, but it's also actually, there are a lot of specifics you can wrap around it.
I think one important element is we have to start a dialogue between local industry and local educators, whether that be at the community college level, at the university level, or at the primary school level. And right now there seems to be a disconnect between a lot of educators and manufacturers in terms of what manufacturers think the emerging needs are and what educators think the emerging needs are. So I think, role for organizations like the Manufacturing Institute, so I'll just turn it back at you,
It's your job, Jennifer.
is to help foster that dialogue.
Other thoughts to her question? Amy's extension?
I guess one train of thought is it's more blessed to give than to receive.
Right.
So that philosophy has to permeate your workforce and your organization, and at least with our organization, I would think with any organization, you know, your customer base is your community. And so you have to engage and pour into your community, because if you don't have a vibrant community, then your business or your organization will have a difficult time succeeding. You want your community to be very attractive to workers, to your employees. You want to have a vibrant community. So I don't think there's anybody who doesn't want a vibrant community, but sometimes we don't always recognize that pouring into the community is how you maintain and keep a vibrant community.
Didn't we talk about community college experiences? And because my observation is actually that the leading manufacturers are investing in the outreach. They are investing in that combination of training and development for their own workers. They're creating alliances with community colleges and others. It's often not well known. It's actually not, they don't do it for a PR perspective, but they do it largely because they know they need the skills and the talent that are necessary. But
That's true. At the Carbon Fiber Technology Facility, for example, we've got a partnership with Roane State University, which is a local community college, to train technicians, and we have them come in and work in the facility. So it's not only a good community activity, but it's a good business sense. It's something we need to have the skilled workforce to work in the carbon fiber industry.
But oftentimes those community colleges are not where the greatest needs are. And we talk about bringing advanced manufacturing back to the United States in a major way, and taking opportunities in some degraded areas where perhaps there will be easier all kinds of incentives to locate there. But we have, when we first started looking at these issues, we were worried about the lower quintile of the workforce, or the non-working part of the would-be workforce. Now we're really worried about the lower 2 quintiles, that's being generous, of the workforce. And Craig, just to get to your big point about competitiveness and looking at the Brazils and the Indias and the Chinas, China and India, of course, they have these massive middle classes and this voracious consumption for stuff and services. But they also have the biggest, by far, impoverished populations.
they got a long way to go.
They have a long way, but we also have a long way. And it's easy to cherry pick and say, oh, wouldn't it be great to make these connections with, and Oak Ridge has done amazing work. I've looked at what you've done, and it's terrific. We also need to reach into communities where there is no hope.
So another question?
I agree.
Indeed, I've been watching the Twitter feed, Brent Wild from the Manufacturing Institute, and so there's some definitely been some interest in this couple of tweets. We love exemplary schools that embrace STEM education and these kinds of innovative practices. How do we replicate them across the United States?
Okay, good question.
This example I gave of Tracy is one of many, many really nice models. It's replicable because it happened in a very difficult to educate population. They spend $1,000 less per student because they're punished by the California system for being a charter. So it's very low cost, very, very low cost compared to Washington, D.C. public schools, where we are right now, where I think it's one of the highest per pupil in the country. And it's online. The teacher training, as Chris said, is critical. You've got to get the teachers on board and get them motivated and extremely saturated with the material and very flexible. But it is very replicable.
How much, Bill, go ahead.
What were you going to say?
How much of this is a funding issue? I mean, your budgets, you're out, actually all have specific projects you're working on. You've got you're all funded differently, very differently. But in order to do this, you've got to decide to carve out part of that to go, collaborate in something like this.
Yeah, well, Fraunhofer is a private sector entity. We're nonprofit, and we have a certain amount of funding that we call base funding. I mean, in Germany, the organization is funded approximately 30% of its budget is provided by the government, and the rest has to be earned by doing contract research for industry and also for government. We do the same thing over here. But addressing the question about how do we get more of these types of schools and so forth, I think that the fundamental thing that has to happen is that there has to be a realization that all of this relates to economic development.
Right.
And since it relates to economic development, states should be highly competitive in wanting to attract the industries, the people to their state, and in order to do that, they have to be able to provide local talent. So perhaps the pep talk has to be given to the governors. Many of them are already well aware of it and are doing things. But if the states become more competitive in creating charter schools and so forth, and providing motivation for innovation in the public education sector, then I believe that you'll see that things will improve. Because if there's one thing for sure in this country, we always advance if we're competitive. And if we can be competitive, more competitive internally, we will probably produce better things.
Okay, got another question.
Thank you, panel. I'm Mary Gershwin with U.S. Brazil Connect. And my question is about something that really hasn't come up so far. And we know that fewer than 3% of the students in higher education in this country study abroad. And yet countries like Brazil is investing, sending 100,000 students to study abroad for a year. It's over $1 billion investment to send, and it's specifically for students in STEM fields. If you go to universities in the United States, we know who's in STEM fields, and countries are investing in sending their students abroad and in doing it at a really, at a significant level. We have a partnership with the Brazilian Confederation of Industry to take U.S. students to Brazil on paid internships, but it's just one. We're growing to 50 students, to 70 students actually this year. But there are so few opportunities for that. And my question is, how are we going to build a competitive, engaged workforce if we continue to just stay within the United States and don't really pay attention to that experience? And if we also continue to do it primarily with students in the liberal arts who go abroad. And do you see a piece of that in terms of what needs to change in this country? Is that something you're thinking about and think is important?
Well, I would say number one, looking at the difference in the cultures is very important in order to be able to gain by blending with people from the other countries, exchange student programs and this sort of thing. We have in our organization many interns that come approximately. We have 6 research centers in the United States. We have about 80 interns a year coming into those research centers. Of 80, approximately 50 to 60 of them are from other countries. All right? At the same time, we do not send many of our people elsewhere. So the cultural experience is all in one direction. In other words, people who come here learn more about our entrepreneurial spirit, learn more about the way we do things. We, in turn, are not really learning a lot about their needs and how they do things. So I believe that it would be very beneficial if we can have true exchange, more of it in both directions. Not between the U.S. and Germany, but in the developing countries, certainly, that makes a big difference. Yeah.
I think it's an interesting question because anymore, much of the innovation is global. I have clients that have integrated product teams that are literally working on the same application to develop something where they have folks in Ohio, folks in Europe, folks in Asia, all working on the same team. And so they have to, and one of the big challenges is to understand each other's cultural approaches to things. It's not all just technical.
Right.
So, I think maybe more exchange would help facilitate that.
Okay, we've got one more question in line. We have time for that, and then I've got one last question to each of the panelists. So.
Thank you all for the great insight. My name's Charlie Cerati. I'm the CEO of Independence LED. So we brought our manufacturing actually from China to Boyertown, Pennsylvania for the high efficiency lights.
Great.
I have well, thanks. I have a study that came in just last Tuesday. We did an outreach to hundreds of schools around the United States. So we have 62 interns in the program, of which over 90% are from either China, Asia, India, and overseas. So this is, I believe, a branding crisis for manufacturing, where the demand is for us not about trying to change how they're trained or what they're doing in school, but why they want to even engage. So we started to shift the way we describe our company as a manufacturer to an energy technology provider. And I put this on the table only because in Craig's opening with the study, there was discussions about how you may want to be part of something that's energy or technology,
Right.
but you also want manufacturing in your backyard. I put it out there because I think to this panel and also to the group, there is a way to influence change from the top down and create demand for what is in the history of the world now a significant chapter, Industrial Revolution, and the young group, these are 20-somethings and teenagers basically coming out of high school and college, believe that manufacturing equals their grandfather's business. Then there was the technology revolution with the information age, the internet, and now we are upon an energy revolution. So we have built momentum, and I was delighted to see the response across the country for the internships, but to see the lack of interest from the American residents, this multinational, was an incredible shock. I thought it might be 50 cents on the dollar in terms of that split, not 90 or 95. So I put it to the panel here, which is, can we take the branding initiative as a way to start from the top down to send a message that this is a new opportunity, a patriotic opportunity for America to take a leadership role in this new energy and technology revolution and include manufacturing as part of the solution, not a perceived historical part of the culture.
So, Johnny, you're right in the middle of this, right? I mean, that's Oak Ridge National Lab.
We're definitely in the middle of it, and when you talk about the next generation or the current generation, a lot of the students that I interact with or hear from, or if I look at their resumes, they talk about clean energy, environmental impact, want to do good things, So I think that messaging would help make it more attractive, and I think that's a large part of what we need to do in terms of educating, messaging, and even your iPhones, that has to be manufactured somehow. That just didn't appear. And you have to know math and science to be able to create this. I think connecting the dots, so to speak, would be great, and I think you've laid out a great solution to that.
Bill?
We have a center in Massachusetts called Center for Sustainable Energy Systems, and we're one of our today approximately 40% of our activity there is on building energy efficiency. Now, building energy efficiency is something that most people don't realize how much energy is used in buildings in this country, but it's like half of all the energy is used in buildings. And building energy efficiency in Europe is something that people have grown up learning to respect, and they practice it. And it's a cultural thing to turn out lights and all this sort of stuff. Behavior is quite different than here. They're much less wasteful. But building energy efficiency for us is how to renovate old buildings, make them more energy efficient, at the same time innovative ideas for new construction. We are renovating in South Boston a 110-year-old building. We're spending $25 million to do that. We are going to be occupying it as our research center. It's 6 floors, it's 50,000 square feet. We basically gutted the building, putting it back together, and we're building it in such a way that we call it a living laboratory, in that we can have visitors come into that building. They can take an iPad and they can point it at the floor, and they can see what's underneath the flooring. They can see the thermal heating system that's there. They can look at the insulation in the walls. They can look at the solar panels on the side of the building. They can see the meters that tell you what everything is going on and how energy is being generated and how energy is being conserved. So it's a combination of a laboratory for us to do what we do, but also to get the message out to visitors, public, students, and so forth, to come in and see how technology can actually improve. And it all comes down to something that in this country it should be more important than it has been, and that is to be less wasteful and to be more cost conscientious. And of course we're being forced into that now, aren't we? I mean, it's going to become even more of a practical thing to be cost conscious, and so that means be energy efficient as possible.
May I add one very fast comment?
Sure.
Which is, I think you're absolutely onto something. And we should be celebrating the technological capabilities, obsession of our youth. And with all of the major challenges we face in terms of rebuilding our infrastructure, whether it's retrofitting buildings or establishing new grids, we need to show them the technological applications that they're so comfortable with can really help develop these new capabilities so we can manufacture. Can't manufacture without infrastructure.
Okay, so with that, we're actually out of time. Thank you very much for the questions, audience, and I'd like to thank the panel. Mr. Hartman, Conrardy, Dr. Johnny Green, Amy, thank you very much.
Great. As we move to a quick 10-minute break, thank you again, Craig and panel members. I'm going to start to see if I can't pull forward some themes for you guys to think about, and to those whose questions we didn't get to, we clearly will have a chance to get to them through some of the panels, because I know they're talent-driven. I'm starting to hear the theme of image and exploiting the obsession of youth. And the other comment is sort of we need to create the next Sputnik. And that, again, comes back to it's really about these technology-driven innovation and the talent and the kids that we know want the gaming and want the technology. So a 10-minute break, then we're going to open up with a video in our next panel.